Another quadratic inequality, all set up really well for us. This part's already factored, this side's already equal to 0. So if we come across these things and they don't look this way, the first steps you would take is to get one side equal to 0 and then to factor this thing out. Now that it already is factored, though, we'll just go ahead and figure out that the points of interest will be +1 and +6. +1 because that makes this 0, +6 because that makes this 0. I'm going to throw those on my number line over here. I'll put the 1 over here and the 6 over here. And might as well figure out right now if I'm going to be doing an open or closed circle. The values we want should definitely be less than 0 but not equal to 0. And the 1 and the 6 are what make it equal 0. So we do not want to include them. So we'll put an open circle saying we want to be here but not actually like on here. And now we're going to go through with this sign analysis of this product and see what's going on. So again, these 2 points break the line into 3 separate regions. And we're just going to take one number from each region, plug them in over here, and see what the sign of the value is going to be. Will it be negative and less than 0 or positive and more than 0? So a number from over here, I would say 0 or negative 18 or negative 10 billion. I like to just think like negative, 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 and very, 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 very huge. So a huge negative number -1 is still a negative number. A hugely negative number -6 is still a negative number. And then a negative number times a negative number will always be positive. So this will be positive. Positive. For the middle section, I might pick, well, any number between 1 and 6 that I want. So maybe I'll pick like a 2. 2 minus 1 is positive. I actually know the answer, but I don't care about the answer. That's why I'm not saying it. And then 2 minus 6 would be a negative number. So we have a positive times a negative, which is always negative. So this will be negative. And then I'll pick a gigantically huge number. So 10 billion minus 1 is positive. 10 billion minus 6 is positive. So I have a positive times a positive, which is still positive. And then we just want to figure out which of these regions satisfies my inequality. So when are these numbers going to be less than 0? Well, when they're negative. So that's in between here. So I'd want to shade all the stuff in between. This would be my number line shading if I had to do that. If we wanted interval notation, we can go ahead and put a round parentheses on the 1 and a round parentheses on the 6. And this would kind of indicate all the stuff in between. So these are both your answers, both 2 ways to represent your answer. By the way, if ever all my like abstract stuff of like, not showing calculations is stressful to you, then you can actually do the calculations. So if you get what I just said, you can stop this video now. But if you were like, dude, can you explain that a little bit more? I'll just say like, when I was starting off, I was probably, and I do something over here, I might just pick something like a negative 10. And I might say, in this region, if x is negative 10 minus 1 times negative 10 minus 6. And I would actually maybe do that calculation. Negative 11 times negative 16 is positive 176. But after I did that enough times, I realized I didn't care about the 176 at all. I cared about the positiveness of it. And that's what I'm really trying to emphasize with you guys, is that you look at the sign, the sign, the sign. And that's also why it's so critical in the beginning to have one side equal to 0. Because then all that really does matter is the sign. So keep chewing on that if it's not making sense. And Alex explains it slightly differently, so maybe you like the explanation better. And if not, you can always shoot me an email too. Good luck.